Okay. Listen about radical equation. This is easy identification because it's an equation that contain radical. Contain radical. Entonces, what is the procedure? What is the key word? What is the key idea? Key idea for solving any radical equation. Okay, and number one is isolate the radical. In this example is isolate. Number two is square both sides. Because I know when you square square root, the answer is any because this and this is cancelled. Now, after you manipulate the new equation without radical, so you eliminate the radical. Now, after you manipulate the equation, the rest is algebra. And finally, you solve for And very important numbers, 4 step is checking. It's mandatory this. Okay, the rest of the equation that we studied before is not strictly mandatory, the checking part. In this case, yes, it's mandatory because sometimes we have extraneous solution. You see in the example. Okay. Okay, let's go to this example that is very, very elementary. The radical is already isolated. Good. You square both sides. When you square the square root and the square cancel, stay q plus 1 without radical. In the right hand side, we have 7 times 7 is 49. So for q, subtracting 1, q is equal 49 minus 1 is 48. And the answer is q equal 48. However, you need to check. Mandatory check in this equation.
Yes, it is.
Yeah, yes, it is. It's obvious it is. Not necessarily right by intuition. You plug it in here. Look, but I want to see. 48 plus 1 should be. I claim that. Question mark 7. 48 plus 1 is 49. The square root 49 is 7. 7 equals 7. You get true statement. That's mean. Okay, 48 is solution. Okay? This is the basic idea. Of course, I want to complicate more this. Equations that contain one radical, two radicals, so it's more long process. When you have two radicals, so you isolate one first, square, and we need to eliminate this first radical, and you isolate after manipulation algebra, isolate the second, and you square again. So it's a long process, I know, but it's no big deal. It's easy. Okay. Any question? Clear? Let's do one more example. Similar, very, very similar. 7q minus 6 equals 6. Okay. Remember, step 1, isolate the radical. This radical is isolated radical. Square both sides. 7q minus 6 without radical equals 36. It's 6 times 6. 7q is equal to 36 plus 6 is 42. Divided by 7. Q is equal to 6. Okay, I need to check it. Here. I claim that square root 7 times 6 minus 6 should be equal to 6. 7 times 6 is 42. 42 minus 6 is 36. Square root 36 is 6. Okay, solution 6. Any question? Radical equation. Are you copy? You see? Okay. Okay, number 3 is similar. Number 3 is square root 5q plus 6 equals 6. I am doing the problem in one package I sent yesterday. Did you receive, right? The package yesterday.
Yes.
Okay, number 3. Number 3, again, similar, you square both sides. 5q plus 6 equals 36. Subtracting 6. 5q cancel equals 30. And divided by 5, both sides. Q6. Now the checking part, mandatory. I know that you don't like, but it's mandatory. It's square root 5 times 6 plus 6 should be equal to 6. Remember, order of operation. You are doing the multiplication first. This is 30. Should be equal to 6. This is 36. And the square root 36 is obvious as 6. Again, this answer is correct. Okay, sometimes it's weird it happens. The answer is incorrect, but sometimes the checking is mandatory. Okay, now I want to solve some equation that contain 2 radicals. This is a little bit more complicated. 2 radicals more complicated. May I erase the board? Because I need more space.
Yes, sir.
Okay. Super. Okay. Copy number 4 example is square root 3x plus 1 is equal 3 plus square root x minus 4. Remember, step 1 is isolate one radical. But this is already isolated. So this radical is already isolated. So I take advantage of this. Also, I recommend that you copy, rewrite again the equation. Why? Because I need to take completely identical the original, because the original I reserved by the checking part. So I strongly recommend in the complicated equation you don't touch the original. Okay, you rewrite now, ready to square. You square both sides. Square here and square here. This is 3x plus 1. That was the intention. Eliminate the first radical. And then the second part is different because this is binomial. 1, 2. So it's actually 3 plus radical x plus 4, h minus 4, sorry, f minus 4. Multiplication by itself, no? It's multiplication. Basically, the thing we're doing now is multiplication to binomial, and you FOIL. Okay, 3 times 3, 9. 3 times radical, remember, 3 times radical, you multiply 3 times the coefficient here, que es 1. So it's plus 3 radical x minus 4. And radical times is exactly the same, 3 times radical x minus 4. And this situation happens because they are identical. Because they are doing both. Actually, we are doing multiplication a one binomial times z, ¿no? Entonces, and finally, the last is multiplication radical times radical. And remember the idea that we studied last class, radical any expression times radical any expression is equal any without radical. Yeah, take advantage. X plus 4, x minus 4. Sorry. Okay, FOIL, 3 times 3 is 9. 3 times radical is 3 times radical. Radical times 3 is 3 times radical again. And radical times the same radical is the same expression inside the radical without radical. Okay, now we are ready to combine later. 3x plus 1 is equal. Let me see. We have 9 here. We have 4 put together like a 5. And 9 minus 4 is 5. And you have 3 radical something plus 3 radical something is 6 radical something. Plus 6. So at least we reduce a little bit the size of the equation. That's too long. However, when you combine later, 9 minus 4 is 5. And 3 radical something plus 3 radical something is, remember the property is 3 radical something plus 3 or any number radical something is 6 radical something, no? And we come from this 6, 3 plus 3, 3 plus 3. And 4 is 7, no? You are in the number. But in this case, they say, okay, what should I do now? Well, okay, we have another radical equation. I need to isolate the second radical. The law is long, but it's the only way to do that. Okay, so I propose you isolate the second radical. So I move 5 to the left. I move x to the left. And 6 radical x minus 4 stay in the right hand side. And one more time, we combine later. Who is like, let me see, 3x minus 1x is 2. And 1 minus 5 negative 4 equal 6 radical x minus. Everyone follow me so far? Confusing? Clear? Yes. Eso, bueno. Okay, entonces I can see in that moment que the coefficients in front my equation is even number 2, 4, and 6. Ooh. It would be fantastic in order to simplification a little bit is divided by 2. Suppose that some students don't apply this idea because don't realize this idea. Okay, you get the same answer like me. Well, the only disadvantage is your number is down by number, no? But it's okay. You divide the entire equation by 2. 2 by 2 by 2 by 2, everything by 2. But by 2 outside, not inside. Because you divide by 2 outside and inside, you divide actually by another number. To make fair, you divide by 2 only outside. This is x, 2 is cancelled, 4 minus 2 is 2, and 6 divided by 2 is 3. Okay, this is the easier equation. I reduce a little bit now. Okay, ready. We are ready now to square both sides. Because the square, I know, can allow me to eliminate this radical. Okay, so you multiply x minus 2, x minus 2 in the left hand side. Let's do it in the left hand side. It says FOIL x squared minus 2x minus 2x again. And negative 2 and negative 2 is positive 4. Okay. It's always when you apply FOIL, we combine later. This is x squared minus 4x plus 4. That was in the left hand side. And the right hand side is different because actually it's 3 multiplied by a radical. So you multiply, no, you raise to the second power. So 3, it's like that. 3 squared times radical x minus 4 squared. And 3 squared is 9. And the radical square is cancelled. It's just x minus 4. But be careful. You keep this parenthesis. Because if you write without parentheses, look at that, what happened. Suppose you make this mistake, x minus 4, and no parentheses. So I suppose that this 9 multiply only x. This is incorrect. So the parenthesis is super important. So it's 9x minus 4. If you want, you apply this trivial property here. 9x minus 36. Can you copy that? Okay. Almost, we finished, almost. In this moment, I realize that we have quadratic equation. How do you know quadratic equation? Because these two indicate me square. Quadratic equation. It's an equation that contains exponent 2, at least one. And the only possibility that we studied so far today for solving this equation is by factoring. And by factoring, we need that the right-hand side must be 0. I bring 9x and 36 to the left. Minus 9 plus 36. Okay, and we combine like that one more time. We combine negative 4 and negative 9 is negative 13. And positive 4 and positive 36 is 40 plus 40 equals 0. Okay, nice. And then in this moment, we have trinomial. What kind of trinomial we have? Regular trinomial, because the coefficients here is 1. So it's super easy. You open two parentheses, you put the name of the variable as x, and you try to find a combination. Give me two numbers that multiply each other, give me 40, and somehow when you adding or subtracting, give me 13. Who helped me to find that?
5 and 8.
Exactly. Exactly, 5 and 8. Very well. What sign? What sign? What sign? What sign?
8 is negative?
Both?
No.
No?
Yeah, both.
Both. Yeah, you are right, mister. Remember, I repeat 40 times. I want to repeat 41 times. When this sign is positive, we expect the same sign. And negative both because this sign is negative. Okay. Now, x minus a is 0 is one equation, or another equation is x minus 5 equals 0. It's obvious that the first solution is 8, and the second solution is 5, positive 5. But I don't finish, unfortunately. I need to check it. I'm checking both. Okay, it's too long process, I know. Okay, this is the beginning. Look. Okay, now let's do the checking part. And just I propose you the following organization. Look, to checking. Good and efficiency. You split the paper into parts. And you copy here, check. 4 x equal 8. And check 4 x equal 5. And verification is true or no. Okay, because this is challenging. I don't know if it's true. Because I take the original equation. I never using, I take the original, this one, I copy here. But you replace the square root 3 times a, you replace x for 8 plus 1 inside the radical equal, should be, I claim that Because I am not sure that this statement is true or false. 3 plus radical 8 minus 4. Likewise, I am doing for 5. So it's a square root 3 times 5 plus 1 should be 3 plus radical 5 minus 4. But let's do it one by one. I respect the order of operation. This is the order of operation. 3 times 8 is 24. Let me continue on the left hand side. 24 plus 1 is 25. And the square root 25 is 5. So the left hand side is 5. The right hand side is 8 minus 4 is 4. And the square root 4 is 2. And 3 plus 2, of course, is 5. Okay, therefore, the answer A is perfect. When you write solution set, you open A, comma, something. I don't know if 5 works or doesn't work. If it works, I put comma 5. If it doesn't work, I don't put comma 5. Okay. Again, order of operation, 15. Square root 15. 15 plus 1 is 16. And the square root of 16 is 4. And the right hand side, 5 minus 4 is 1. And the square root of 1 is 1. And 3 plus 1 is 4 again. Okay. Both solutions work. But we have in this question 2 solutions, A and 5. Any question? Wow, ¿tú lo ves? Everyone understand very well or no? Come on.
Yes.
Sure? Okay. This is important, guys. And we continue when you taking after the October 26th, we start college algebra. In college algebra, we reinforce this radical equation again. Of course, more complicated example. But this is the introduction to the radical equation. Okay. May I? You copy or no? What are the technique we are using? You are using? You copy your notebook? You watching the video? Or only you watch it without copy? Some people prefer the antique way, no, to use a notebook. Do you prefer notebook or you just watching the video, no copy anything? Come on. Opinion.
I take a screenshot and after I copy, I practice
Okay.
them on my
Okay,
book.
super. This is the new way. Take a picture, image. Okay, good, very good. You create your own way. You create your own way. Okay, I want to raise the bar to keep going to the next problem. Next problem is similar to radical. We have to practice to radical. This is the problem number 5. 5. Wait, let me make it zoom to see much better. No, not much. It's okay. Number 5 is square root 2x plus 3 minus square root x plus 1 should be 1. Equal 1. This problem bring me new idea, new complication, new. Remember the first step always is isolate one radical. So in this case, no, we have two radicals together, no? So you have to isolate one radical. Then you make a decision what radical you prefer isolate. See, the first or the second, either way, doesn't matter what do you isolate, the answer doesn't change. I make a decision to isolate the first. I call the first this. First radical. So I bring the second radical to the right hand side, like a plus. And this is my new equation. It's equivalent to the original. But remember, I reserved the original for the last moment, que es the checking part. Okay? Now square, both sides. Square fantastic, because the square allows us to eliminate the radical. Because at least we have only one radical deleted. And you FOIL. FOIL, I prefer copy like a two binomial. 1 plus radical something and 1 plus radical something. No? And you FOIL. 1 times 1 is 1. 1 times a radical is just a radical. X plus 1. It's expression inside. A radical times 1 is exactly the same. Always happen the same. They are twin brothers. And a radical times a radical is the expression without radical. Everyone follow me? Do you understand very well this FOIL? Okay, now combine.
No, I don't understand this second
Okay,
part.
okay, no problem. I explain to you in detail. Look at that. We are doing the following multiplication. Look, 1 plus radical x plus 1 times 1 plus radical x plus 1. And you remember FOIL, correct? FOIL means first is 1 times 1, is 1. O is outer is this guy times this guy, and 1 times radical is obvious que es radical. Now what's the next? Inner. I. Inner. Inner is radical times 1. Is in this case always happen. Well, always happen in this case is twin brother. It's the same. Because the square root x plus 1 times 1 is the square root x plus 1. And last is square root. Look, square root x plus 1 times square root x plus 1. Que you know que x plus 1 is x plus 1 without radical. Do you understand this or no?
Yes,
No?
sir.
Then it's exactly the same. I copy, but no copy vertical, I copy horizontal. This one is this one. This radical is this radical. This radical is this radical. And this is this expression. No problem? Super.
Thank you.
Pleasure. Okay, now what should I do when we combine like that? We combine. How we combine? When we copy, I copy 2x plus 3. This 2x plus 3 I copy here. I can see the 1 plus 1 is 2. Look, we put together lighter is 2. And the radical plus a radical is twice. And stay alone x. Everyone follow me? Combine like term. There are no reason to have one and another one. No, it's a light term put together. And the radical plus another radical gets the same radical, so you combine like term. You put twice. What is the next step? The next step is try to isolate this radical. Okay, therefore I move everything to the left except this. And 2x stay plus 3 minus 2 minus x equal to radical x plus 1. I'm ready to combine 2x minus x and 1x. And 3 minus 2 is 1, positive. In this case, was not necessarily divided by 2 because this is 2, this is even, but this is not even. So it's the lowest term. Entonces, my recommendation in this case is eliminate the second radical and use square both sides. Square both sides, square here, square here. Remember, this is binomial, and the multiplication of the binomial one more time, we use FOIL. is x squared plus 1x plus another x plus 1. And we combine x squared plus 2x plus 1. Okay. And the right hand side is different because it's square, but this is not binomial. It's a binomial, but inside the radical. But together, so, it's not binomial. It's 2 squared and square this. This is 4. And the radical and the 2 is cancelled, but stay the parentheses. Don't forget the parentheses. This parenthesis is the most important thing, in my opinion, in this equation. And you distribute the property now. 4x plus 4. They copy on the right hand side, 4x plus 4. Again, we have quadratic equation. I suppose we have 2 solutions. I don't know if the solution work in the original equation or not. Remember, the thing we are doing is you manipulate algebra. You say you transform it. The original equation that was radical equation and another equation that is radical, a quadratic, equation. And they are equivalent a little bit, but not always 100%. In some case, yes, but in some case, no. So you need to verify. Okay, so I propose always when you try to solve a quadratic equation, we express it in standard form. The standard form, remember, is ax squared plus bx plus c equal to 0. So the right hand side must be 0.